Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is typical examples for FMEA and FTA to support the quality risk management. Among the 9 quality risk management tools, FMEA and FTA are predominantly used for routine manufacturing for compliance to GMP for addressing the risk assessment as per Q9. Let us understand the intent and the concept of FMEA. FMEA provides for an evaluation of potential failure modes for processes and their likely effect on outcomes and our product performance. This is referred as Section 1.2 in the Annexure 1 of the QRM Guide Q9. This also is referred in International Electrotechnical Commission Series number 60812. So the Section 1.2 of the Annexure 1 of QRM tool says FMEA provides evaluation of potential failure modes that lead to likely adverse effect on the product quality and long-term performance of the product. Let us try to understand more. FMEA tool is very useful when you initiate any new installation and qualification of equipment or a change control for any changes in men, machines, methods and materials in GMP. Guideline prescribes that FMEA can be applied to equipments and facilities and might be used to analyze a manufacturing operation and its effect on product or processes. So you have to initiate a fishbone diagram with men, machines, materials, methods as inputs basically. This is a simple design, a fish skeleton design with problems merging into the spine and moves towards its head as the cause of the problem. See these examples how a potential failure will lead to likely effect and the risk involved. So FMEA tool will work effectively and methodically breaks down the complex process analysis into small manageable steps. This tool summarizes all important failure modes. So you should focus on all minute aspects of failure modes into this fishbone for analysis in a scientific way and in a comprehensive way, focusing on all yams that are described in the fishbone. Let us see some examples of FMEA. See this table. This table depicts how men, machines, methods and materials are addressed with the details of potential failure, likely effect and the involved risk. This entire set of examples cover all potential M's that are part of GMP. See, for example, the operator is not trained. What is the likely effect? It ends in a faulty operation. So what is the risk? The risk is the inferior output. Similarly, not the appropriate person, that means he is not the right person to do the job. What happens? He endangers the process step. Because of that, you will have a product loss or damage. The temperature indicator is not functioning properly. This is a part of the machine. Reaction mass exposed to high temperature because we are not sure of the temperature. So product can fail in organic impurities or any other failure. Leakage of valve. If there is a leakage in valve, there is a loss of product. The risk is the lower yield than expected. In the methods, if there is no procedure available for the activity, the operator will not be able to carry out the job effectively. That is the likely effect. What is the risk? The risk is the output is questionable. We are not sure of the quality of that. No test procedure is available for testing a material. The material cannot be evaluated is the likely effect. So the risk is no knowledge on the quality of the material. Similarly, inferior raw material is used. This is a part of the materials. So inferior process intermediate will be formed. So inferior quality output and inferior quality product is the result. Wrong material is used. No reaction, batch fails. Of course, this may be the likely effect. The risk involved may be, it may be an accident. Accident may happen if non-compatible material is used. So it is very important that your fishbone diagram should include all this type of questions for men, machines, methods, materials in a very, very minute way to get the best results out of your assessment. Let us see how the risk classification is done for FMEA. See this chart. In the scenario 1, risk for severity is low, risk for probability is low, and risk for detectability is also low. That means the overall risk is low. Scenario 2, risk for severity is very high, risk for probability is also high, risk for detectability is also high. That means everything is high. So overall risk is high. In the scenario 3, the risk for severity is high, but the probability is medium. That means even if the risk for severity is high, the probability of occurrence is not that high. It is medium. And risk for detectability is low. That means the severity can be detected very fast, very well. So the overall risk can be classified as medium. See the scenario 4. The risk for severity is high. Risk for probability is medium. That means the occurrence of probability is less or medium. But the risk for detectability is high. That means the severity cannot be detected so easily. So the overall risk is high. See the last scenario 5. Risk for severity is high. Risk for probability is very low. That means it is very, very infrequent. Risk for detectability is also low. That means the severity can be detected very well in the process. So the overall risk can be classified as low. I hope you understand the classification. Let us see what is FMECA. FMECA is exactly same as FMEA. But there is one difference. What is the difference? It is the C. C is the criticality. So criticality is done based on the risk and risk number. You have to give a score for this. So conceptually it is exactly same as FMEA. But in FMEA we are classifying the risk with qualitative terms like low, medium and high. Whereas the risk is classified by risk rating and overall risk is determined based on the criticality score by multiplication of the product severity, probability and detectability in FMECA. Let us see this example. The same previous example, the example in the previous slide. Same about 5 scenarios are here. And here you have given a scoring between 1 and 5. 1 being the least or low risk and high being the most high risk. So if you see the first one, the risk for severity is low, risk for probability is low, risk for detectability is low. So all are 1. So 1 into 1 into 1 is 1. Risk for severity is very high. That is on the maximum number. Risk for probability is also maximum number and risk for detectability is also maximum number. So 5 into 5 into 5 is 125. that is high risk. See the third one, risk for severity is high, but the probability is 3, that means center value, and detectability, risk for detectability is low, so 15 is the multiplication of SPD, so that it is medium. But see the fourth scenario, risk for severity is 5, probability is 3, and risk for detectability is also high, it is 5, so that becomes 75, so this again becomes high. Similarly, risk for severity is high, risk for probability is low, risk for detectability is also low. This is also, number is only 5. If you compare the previous slide and you get exactly the same content and the same classification whatever you have done in the earlier slide. So based on the multiplication product of S, P and D, the risk classification is done in the following way. On a 1 to 5 scale, the score between 1 and 5 is considered as low risk. The score between 6 and 74 is considered as medium risk, and the score between 75 and 125 is considered as high risk. But if you see on the scenario 4, the risk for probability was considered as 3 and the final score was 75. But if the score is 2, the final multiplication score will become 50 and that is considered as medium risk. Whereas if the score is 4, the final multiplication score will be 100 and that comes as high risk area. So if you see the previous qualitative evaluation done using FMEA and the quantitative evaluation done using this FMECA using scores is same, exactly same. You can see the chart in both the cases. Let us see how the FTA, that is the fault tree analysis tool, works. The FTA tool, you can also see the IEC number 61025, is an approach that assumes failure of the functionality of a product or process. So let us examine the FTA tool. It is a failure of a functionality, and FTA operates in the opposite direction of FMEA. To understand easily, let us see an example. A car driving at a very high speed, this is the failure mode, can cause an accident. This is the likely effect and risk. This is FMEA. This is how the FMEA works. In FTA, it works in the opposite direction. That means the accident, that means this is the effect, this is the risk, happened because of the high speed driving of the car. This is the cause. So this is the this is some sort of a post-mortem. You can see in this example, when if you in FMEA, if the car is driven at high speed, there is a likely effect of an accident, and in FTA, the accident happened because of high speed of the car. This you have to understand the difference between FTA and FMEA. Let us see how the example of FTA, the same example whatever you have taken for the FMEA is considered here for FTA. So the deviation was the failure was inferior output. The reason for failure was it was a faulty operation. The root cause was operator was not trained. Product loss or damage, this is endangering the process step, was the failure because he was not the appropriate person to carry out the job. Product failed in organic impurities because the reaction mass was exposed to the high temperature. This is the reason for failure. What was the reason for failure? What was the root cause? The temperature indicator was not functioning properly. low yield than expected. The reason was there was a loss of product. This happened, the root cause was the leakage of valve. The output is questionable and not standard quality because operator did not carry out the job effectively. That was the reason for failure. Why? What was the root cause? There was no procedure available for the activity. No knowledge on the quality of the material because the reason for failure was the material could not be evaluated. What was the root cause? Because there was no test method available for that. Similarly, inferior quality of the product because of usage of an inferior process intermediate, because the inferior raw materials were used, that was the root cause. So accident happened because you have used an incompatible material. Root cause is the wrong material was used. So I hope you understand well of these basic concepts of FMEA and FTA. Try to make detailed breakup of all potential failures in the system while incorporating into the fishbone diagram. Make your formats simple and effective while capturing all the details in nice way. Thanks for watching. For more videos, please do subscribe, like, and share. Thank you.